Hi everyone, today we will discuss kinematics. So kinematics, this can also be considered as motion along a straight line or one-dimensional motion. So when we say this one-dimensional motion, it means here if you consider this is your x-axis and this is y-axis. So if a particle is moving only along x-axis, that will be termed as one-dimensional motion. Similarly, if it is moving only along y-axis, then it is one-dimensional motion. If you consider suppose z-axis, let us say z-axis, where z is mutually perpendicular to x-axis as well as y-axis, then if it is moving only along z-axis, so that will also be considered as the one-dimensional motion, means movement along any of these axes, either along x-axis or y-axis or z-axis, so that will be considered as the one-dimensional motion. If a particle is moving simultaneously along x-axis as well as y-axis, let us say a particle is moving along this line, it means if it is moving along this line with the velocity u at an angle of theta, it means simultaneously it will be moving along x-axis with some component u cos theta and some component u sin theta along this line. So simultaneously it is covering distance along this as well as this. So it becomes a case of two-dimensional motion. Similarly, if a particle is moving along x-axis, y-axis as well as z-axis simultaneously, let us say you are moving along this line, then you are moving along this line, and then you move up. So you are moving along this line, you are moving along this line, and then you move up. Okay, so if you move up along x-axis, y-axis, and then you move up, or you move down, so it means you are moving along x-axis, y-axis as well as along z-axis. Z-axis either in the upward direction or in the downward direction. So that becomes a case of three-dimensional motion. So here either it is movement, it will be either one-dimensional, two-dimensional or three-dimensional motion. So right now, as far as this motion along a straight line is concerned, this kinematics is concerned, so first we will consider this one-dimensional motion. We will restrict our discussion either movement along x-axis or y-axis or z-axis, and one by one we will consider the two-dimensional as well as the three-dimensional movement also. Here if you consider this these statements, these are some of the general things that you must know. Mechanics, the oldest of the physical sciences. If you consider the physics, mechanics is the oldest. We have different concepts as far as physics is concerned. We have mechanics, we have sound, we have heat, we have electricity. In electricity, again we have current electricity, electrostatic, that is statics as well as dynamics. In electricity also we have statics as well as dynamics. Similarly, we have modern physics. So there are so many chapters, so many branches of physics. So mechanics, it is considered as the oldest of these physical sciences, and out of this oldest of these physical sciences, we have a chapter called the kinematics. Like again in mechanics we have different concepts. We have the kinematics, we have laws of motion. Similarly, you have motion in two dimensions, we have rotational motion, we have simple harmonic motion, we have fluid mechanics. Like so, there are so many chapters as far as the mechanics is concerned. So we are starting with the kinematics. Now kinematics, here if you consider, it is considered as movement of a particle. Generally in case of kinematics, we consider the motion of a particle, but any body or any system of bodies or an individual, any body, it is also collection of particle. If you consider this object of mass m, so here this is collection of these point masses. So it means depending on our requirement, when we consider the movement of this object, an entire object as a whole, so we will be considering the movement of this entire object as a whole, that is of mass m. Simultaneously we will also be covering the movement of these individual particles which makes this object. So it means kinematics, particularly we consider the movement of the particle, but it is also the collection of the system, collection of the masses. So that is also taken care of as far as this chapter or this topic is concerned. So one by one we will discuss each and every concept, and let us see how this topic move on. Now here in this chapter we come, if you consider this kinematics, it is nothing but the motion is the displacement. Mechanical motion is the displacement of the particles and bodies in space. And if you consider the entire space or the entire universe as a whole, so there are different type of particles, there are different type of objects and system. So here mechanical motion is the displacement of the particle and the bodies in. When we are simultaneously saying this particle as well as the body, because body it is also collection of point masses, it is also made up of different particles. So that's why simultaneously we are taking these two words together or these two concepts together. Now as far as the kinematics is concerned, we will particularly consider the movement of the particle, but at the same time we are not going to ignore the movement of the objects. Okay, when we say an object of mass m, it means it is treated to be collection of the point masses. When it is treated as collection of the point masses, so there also we can apply as far as the principle of kinematics or the laws of or the relations as far as this kinematics is concerned, it can also be used. So we will see all these concepts one by one. Now here if you consider this, now let us consider this reference frame, because when you consider the displacement of a particle, the distance covered, the velocity, the speed, acceleration, it means because these are the measurement. We say that you have displaced for 5 meters. Someone has covered a distance of 10 meters. Someone is moving with velocity 5 meters per second or 10 meters per second. He is moving with the acceleration 2 meters per second square and so on. So these are the statements you are hearing from grade 7, 8, 9 and so on. So when we consider all these concepts, it means if you consider this point and you are supposed standing here, let us say you are standing here. With respect to this point, you are standing at a distance of 10 meters. But if I consider, let us say this point is O. If I consider another point O dash, from this point O dash, it is suppose 5 meters. You are at the same location. You are standing at this particular point. With respect to this point O dash, your distance is 5 meters. But with respect to the point O, your distance is 10 meters. Your location has not changed, but the distance from where we are measuring, from here if I measure, it is coming as 10 meters. From here if I measure, it is coming as 5 meters. It means with respect to two different points, you are at two different locations. With respect, location is same, but at two different distance. From this you are at 5 meters, from this you are at 10 meters. It means there is a significance of this point O as well as this O dash. Just to justify that, we have the concept of this reference frame. So before we start all this, we have to decide a reference frame. Reference frame is nothing but a reference point. Reference point, it means a fixed point from where you can measure all these parameters, whether it is distance, displacement, velocity, speed, acceleration and all that. So with respect to any fixed point or any point, when we measure all these parameter, that point is termed as the reference point. That point will be considered as the reference point, and corresponding to that point we have a reference frame. Like suppose you have this point O. Now if we are measuring all distances, all displacement, velocities, acceleration, distance covered with respect to the point O, then this point O, it will be considered as the reference point. Now consider x-axis originating from this, y-axis originating from this. Then this entire system, it will be considered as your reference frame. So reference frame is nothing but the combination of the reference point, x-axis as well as the y-axis. So this becomes your reference frame. Now whether you are moving along x-axis, so this will decide whether I am moving along x-axis. This line will decide whether I am moving along y-axis. This point will decide how much distance or displacement I have covered with respect to this point O. So first, getting into all these parameters, getting into all these concepts, we have to decide a reference point or a reference frame. Reference point, this point O, it will be treated as the origin, any intersection of the x-axis as well as y-axis, that is termed as your origin in general. Here if you use this with respect to the reference frame, then this will be considered as your reference point. If you are using this x-axis as your reference line, then this becomes part of the reference frame. If you are using this y-axis as the reference line, then again this becomes the part of the reference frame. So this together, x-axis, y-axis and the point O, or the origin or the reference point, that creates a reference frame. So we have this reference frame. Now generally if you consider a fixed reference frame, then earth is supposed to be a fixed reference frame, fixed reference system, you can say. Now anything fixed at the fixed reference system like the earth, that will be considered as a fixed reference system. If it is, suppose if you take a ground surface and you are drawing x-axis at the ground surface, y-axis at the ground surface, you are choosing a point O as origin at the ground surface, then this will be termed as the fixed reference frame. Clear? Now let us say a car is moving, and on this car, suppose this car is moving with some velocity or some acceleration, and suppose you choose this reference line here on top of the car, some line along this, some line along this, and the intersection you name it as O. The car is moving, it means with respect to the car, this reference frame is also moving. So here it cannot be considered as the fixed reference frame, because the car itself is moving. Here if we consider this earth, if we don't consider the rotation of the earth, because that will be considered with respect to some other studies. So if we consider this earth as a fixed object, if we consider that, because earth, with respect to earth, it is supposed to be fixed. With respect to any other planetary motion, it can be considered as it is also a moving object. But if we consider earth with respect to earth itself, then it is supposed to be a fixed object. Now on that you consider a x-axis, y-axis and a point O, which is the intersection of this, then this will be considered as your fixed reference point. Any moving object, if you consider a reference frame at any moving object, that will be termed as the moving reference frame, not the fixed reference frame. So that way we define the reference frame. So depending on requirement, we can take the fixed reference frame, we can even take the moving reference frame. Fixed reference frame, it will be termed as your inertial frame. Moving reference frame, that will be termed as non-inertial frame. This inertial frame, non-inertial frame, again when we start discussing this laws of motion, that is Newton's laws of motion, so we will elaborate all this, the inertial frame, non-inertial frame and all that. You can see what we have discussed just now. A fixed reference system is assumed to be a system of coordinate axes attached to the earth. The curve described by the particle, is as it moves in the space with respect to a chosen reference system is called its path. Suppose you are moving along this line, so this becomes the path of your motion. You are moving along this curve, so this is the path of your motion. So that's what it is said here. These paths may be rectilinear or curved. These paths may be rectilinear, means the straight line, or it may be along a curve. So you can move along a straight line, you can move along a curve. So that will be termed as the path of your motion. And all these things, it will be measured or it will be described with respect to the reference frame. So I hope this is clear. Now here, again this term position vector is coming. So we have discussed in position in vector. So again I will just elaborate it. Position vector, suppose this is your reference frame, x-axis, y-axis and the point O, and you have moved to point P from this O. So this OP here, this is defined as the position of point P with respect to O. So this is the position vector. This is the position vector of P with respect to O. So because O is the reference point, so we are measuring the position of P with respect to point O, so that becomes your OP. Position of P with respect to O. Generally it is represented by the vector R. So you can say R, it is equal to OP. R is the position vector of P with respect to, we can, if you want, you can also put this vector notation over this P. So this is what it is. Position of the particle at any instant is called the position vector. Now let us see, as far as this chapter is concerned, the kinematics, the straight line motion or the one-dimensional motion, or in general any motion if you consider. So we have certain terms which will be frequently used as far as this topic is concerned or the motion in general is concerned. We have this speed. Speed is the rate of traveling the distance without regard to direction, because speed is a scalar quantity. So it is just the rate of traveling the distance with respect, without regarding the direction or without considering the direction. So without taking care of direction, we define this speed because it is a scalar quantity. Here you have this word distance. Suppose again, as we have just discussed, O, and you have this O dash. This length of this O dash, length or separation between this point O dash, if it is suppose S, then S will be termed as the distance between the point O and O dash. Now if a particle is moving from this point O to O dash, so it will be moving with some speed. So that is defined distance covered per unit time. Distance covered per unit time, that will be defined as the speed. Here we don't take care of the direction of motion. You can directly move from this point O to O dash, you can move from O to O dash like this, you can move from O to O dash like this, so that way. But the distance between O and O dash, suppose you have moved from this point O to O dash, so the total length that you have described, that will be the distance covered by you from this point O to dash, if you have chosen this path. The total length of the path that you have covered divided by the total time taken from the initial to the final point, that will decide the speed. I hope it is clear. Similarly, if you choose this path, you have reached from point O to O dash and you have taken this path. Obviously, length of this path, it is different from length of this path. But your initial point remains same, O, and final point is O dash. So you have moved from this point O to O dash, covering this much of distance. When I say this much distance, means the total length of this path. You have taken some time. Obviously, time taken in this journey may be less than time taken in this journey, because distance covered here, it seems to be less than the distance covered in this path. So if time taken here it is less, it means, and distance covered is also less here. So that will define what is the speed that you have chosen, or with what speed you have moved from this point O to O dash. So it means it is the length of the path, that you have described divided by the total time taken, that will be defined as the speed. Similarly, next term is the velocity. Velocity, it is a vector quantity, because velocity does not depend on distance covered. Velocity depends on displacement, and displacement is a vector quantity which is defined as the shortest distance between the point O and O dash. So here in this example, if you say shortest distance between O and O dash is this. Okay. Now, whether you have moved along this or whether you have moved along this, the velocity will depend on this O dash, this shortest distance. So, shortest distance divided by the total time taken, even if you have covered or you have moved along this path and you have taken this time t, so we will not take care of this distance. We will only consider this much, because this is the shortest between O and O dash. If it is suppose x, let us say if it is x, then your velocity will be justified by this x, not by the length of this path or not by the length of this path. X divided by this time t, that will define the velocity here. So shortest distance between initial and final point, that is the displacement, which is supposed to be a vector quantity. Corresponding to that displacement, we have velocity. displacement divided by time, that becomes your velocity. Now, why it is called the shortest distance? Shortest distance means the perpendicular distance between the 2 points. Let us say here these are the two parallel lines. Now, this is also the distance between these two parallel lines, this one. This is also distance between two parallel lines. This is also distance between two parallel lines. But what is the displacement between these two parallel lines? The shortest distance means the perpendicular distance between these two. So you have to drop a perpendicular either from this point to this line or from this point to this line. That perpendicular defines the shortest distance. So perpendicular distance between the two lines or between the 2 points, that is defined as the shortest distance. So it means we will be calculating the shortest distance, that divided by time taken, that will define the velocity, and that shortest distance becomes your displacement. So here we can just summarize: speed, distance divided by time; velocity, it will be displacement divided by time. Displacement is a vector quantity, velocity is also a vector quantity, distance is a scalar quantity, corresponding to that speed is also a scalar quantity. Next comes your uniform motion as well as the non-uniform motion. Now here if you see, the motion of a body may be uniform or non-uniform depending on its velocity. So in case of uniform motion, the speed is constant. Speed is constant in case of uniform motion, and in case of non-uniform motion, it is variable. So in case of non-uniform motion, obviously it is non-uniform, so it is variable. In case of uniform motion, it becomes constant. Now as far as, I hope this is clear, uniform, you are continuously moving with the same speed, obviously it will be termed as the uniform motion. If your speed is variable, sometimes you are moving with 5 meters per second, sometimes 10 meters per second, sometimes 20 meters per second, it means your speed is continuously changing, so that will be treated as a non-uniform motion. Next is the acceleration. Again, acceleration is nothing but the rate of change of velocity. Rate of change of velocity, with what rate your velocity is changing, that is defined as the acceleration. So rate of change of velocity, it is defined as the acceleration. If it is positive, if it is increasing, it means it will be, if the velocity, rate of change of velocity, if it is increasing, it will be acceleration. If rate of change of velocity is decreasing, it will be termed as retardation. So either we have accelerated motion or we have retarded motion. So when it is increasing, it will be acceleration. When it is decreasing, it will be a case of retard. It means when the velocity is increasing, so it means it is increasing because of acceleration. If it is decreasing, it is decreasing with respect to negative acceleration. That negative acceleration is termed as retardation. When I say negative acceleration, it is nothing, not a new concept or new word. It is only with the minus sign. Acceleration with the minus sign, that becomes your retardation. That is the negative acceleration. I hope it is clear. Now that acceleration, again, the change in velocity, rate of change of velocity. So that change in velocity can occur because of the change in magnitude of that velocity or change in the direction of velocity. Either the magnitude of the velocity changes or the direction changes. In both the cases, you will have the change in velocity or rate of change of velocity which will govern this acceleration. So either magnitude will change of the velocity, or the direction will change, or both will change. In all these three situations, we will have the concept of this accelerated motion or the retarded motion. Now let us see some equations of motion, because there are different parameters. Displacement is there, distance covered is there, velocity is there, acceleration is there, time taken is there. How all these parameters are related. So that is guided by equations of motion. We call it as equations of motion. So initial velocity, it is represented by u. Final velocity or velocity at any time, it is represented by v. Acceleration, it will be represented by a. Time taken t. Distance covered, suppose s. So we have these parameters. Distance or displacement, it will be represented by s. Initial by u. This final velocity or velocity after time t, it will be v. Acceleration a. Time taken t. Now if you want to distinguish between the vector as well as the scalar, then we will use a vector notation. If you are talking of the speed, we will simply say v. If you are talking of the velocity, we can write this v. So that way you can distinguish. Or if you are talking of the speed, you can also write like this. Magnitude of the velocity, that becomes the speed. So that way we can treat all these parameters. Acceleration, again, it is rate of change of velocity, not speed. So that is also a vector quantity. Displacement or distance covered, that depending on situation, we can use the vector notation. We may not use it whether we want the magnitude of the displacement. Magnitude of the displacement may not necessarily be the distance covered. So that will depend on situation, and accordingly we will use those parameters. So here, if you relate all these parameters like initial velocity, acceleration, velocity, you can see a uniform acceleration. Again, there is a word uniform acceleration. If acceleration remains constant, as we have uniform velocity or we have uniform motion and non-uniform motion. So uniform acceleration means if the rate of change of velocity remains constant, so that becomes a uniform acceleration. Now that is also changing, that is also variable. Then in that case it will be non-uniform acceleration. Instantaneously, if the velocity is changing, it means it will be a case of non-uniform acceleration. So here A is considered as the uniform acceleration. It means when we consider these relations, so that A will be treated as a constant quantity, not a variable quantity. So using these conditions, so uniform acceleration as A, V is the velocity after time t, s is the displacement in a time t. Here you can see all these vector notation, initial velocity u, v vector notation v, s is the displacement here, and all that. Now we can relate all this. So all these conditions, all these relations we will be using only for the straight line motion. You can't use all this for the curved motion or any other movement. So if it is a case of strictly, I am using this word strictly, if the particle is moving strictly along a straight line, then directly you can use these equations of motion. V is equal to u plus at, s is equal to u plus v by 2 into t. U plus v by 2, this is termed as the mean velocity. In the next few minutes we will discuss this mean velocity also. S is equal to u plus v upon 2, because it is not a case of say u plus v, this becomes your mean velocity. Mean velocity provided it is straight line motion, then only it will be applicable, otherwise this will give you the wrong result. So if it is strictly a case of straight line motion, you can use this relation. Mean velocity into time t, that is also distance covered. If it is a case of accelerated motion, then you can consider s is equal to ut plus half at square. So without this acceleration, you can use this relation. If s, you don't want to involve s, then you can use this relation. If you don't want to involve a, you can use this relation. If you don't want to involve v, you can use this relation. When we say you don't want to involve, that means certain things will be given in the question, certain things are missing. Now on the basis of that, you have to decide whether I have to use this equation, or this equation. So v is equal to u plus at, s equal to half u plus v into t, s equal to ut plus half at square. Next is v square v square is equal to u square plus 2as. Here suppose time is not there or you don't want to use that, then you can use these relation. V square is equal to u square plus 2as. Again s is equal to vt minus half at square. if initial velocity either it is not given or you don't want to use it, then you can write s equal to vt minus half at square, s equal to ut plus half at square. So here it is the reverse. We are using the final velocity or velocity after time t. So we can use s equal to vt minus half at square. Now there is another concept, distance traveled in the nth second. This is your distance covered in time t. Similarly, when we consider this relation, so this is also distance covered in time t. Suppose you are moving with some velocity 5 meter per second, okay, and you have moved for 10 seconds with the acceleration suppose 10 meter per second square. Then what is your distance covered in 10 seconds? So we will simply say s is equal to ut plus half at square. So that will be the total distance covered in this total time taken 10 seconds. But here the question is distance covered in the nth second, means distance covered in the tth second, the last second. If you have traveled for n second or if you have traveled for t second, then one is total distance covered in t second, that is s equal to ut plus half at square. But how much distance you have covered in the tth second, that is the last second. Or if you have total time taken is n, then how much distance you have covered in the last second or n second. So that we need here. This is distance covered in the last second, nth second or the tth second. So how to calculate this? Suppose this is s, distance covered in time t, okay, this total from O to O dash, okay. Now we want distance covered in the tth second, that is last second. So last second, so this distance will be covered for in how much second? T minus 1 second. So this is distance covered in t minus 1 second. Time taken here, it will be t minus 1 second. Here total distance covered is in t second. So how can we calculate? This is the distance covered in the tth second or last. So simply can you say it will be distance covered in t second and minus distance covered in t minus 1 second. Distance covered in t second and minus distance covered in t minus 1 second, that gives you distance covered in the last second or the tth second, because up to here it is t minus 1 second. So from this to this it is tth second or the last second. If it is suppose 10 second and this is suppose 9 second, then this becomes what? The 10th second. So distance covered in 10 second and minus distance covered in 9 second, that becomes the distance covered in 10 second. So st, that will be equal to how much? Ut plus half at square minus st minus 1 ut minus 1 plus half a t minus 1 whole square. Just calculate it and you will be able to get this relation. So instead of t, here we have taken distance covered in the nth second. So it means it is nothing but Sn minus 1. Sn, that will be equal to how much? Ut means un plus half a n half at square. So half a n square. Ut plus half at square. So time taken we have taken n seconds. So un plus half a n square. Similarly, distance covered in the n minus 1 second, that will be equal to how much? U n minus 1 yani ut plus half a t square. So t square means n minus 1 whole square. So distance covered in the last second, that will be this total distance minus this. Simplify that, you will get this relation. So it is distance covered in the n second is u plus a by 2 to n minus 1. So that way we can calculate it. So u plus a by 2, a is your acceleration, n is the total time taken, so 2 and minus 1. Now here it is just the representation. Velocity, you can say, if you want to consider the magnitude of the velocity, so it is mod of that vector v. If you want to calculate magnitude of the initial velocity, then mod of this u, acceleration mod of a, s mod of, so either you represent like this or simply write s. Magnitude, if you want, you write mod of vector A, or you simply write this A without the vector notation. So these are the representation. I can take this mod of V like this, or simply I can take it. I will just remove vector notation from here. I can take this acceleration, magnitude of acceleration like this, I can represent, or simply I will remove this vector notation and this will represent the magnitude of the acceleration. These are the simple representation. Depending on your requirement, you can use the vector notation, you can use the mod notation, or you can use without all this. Now here, if you consider, so there are certain terms like average speed. So this average speed, it is defined as the total distance traveled divided by total time taken. Average speed, because speed again it is a scalar quantity. So suppose you have moved from this point A covering this path and to B. So the total distance, total length of the path as you have moved, total length of the path divided by the total time taken to reach from this point A to B. So that gives you the average speed. Average velocity. Here I have used the word net instead of total. Net because in case of displacement we have to take care of the direction. So it is net displacement upon total time taken. Now A to B, if you have followed this path, length of this path gives you the total distance covered. But you have moved from this point A to B. So what is the distance covered? Whether you have taken this path or whether you have taken this path, the displacement will remain same. Either you say displacement or the net. That is the shortest distance between A and B, and shortest it will be, let us say, along the dotted line. So this becomes the shortest distance, and that becomes your displacement, because if this represents the perpendicular distance between the point A and B, so that will be your shortest distance, and that will be the net displacement or simply the displacement. So the net displacement upon total time taken, that will give you the average velocity. Mean velocity you can consider. This mean velocity, it is again initial velocity plus final velocity divided by 2. Here you can see we have used this vector notation because initial velocity, it can be, or final velocity, both of can be in the same direction, then there is no problem, simply u plus v upon 2. But if they are in the different direction, you start along this and finally you are moving along this line, this curve. So finally your final velocity is v here. Initial velocity is u here. You have changed the direction of your motion in between. Okay, then how to consider this? So take the initial velocity, take the final velocity, average of these two velocities, so u plus v upon 2. That gives the mean velocity. So simply magnitude of u plus magnitude of v upon 2 if you consider, so that can be considered along a straight line. If there is no change of direction, then it is easy to calculate. If there is change of direction, then you have to take the average of or the mean of their vector addition, not the scalar addition. In case of straight line motion, if you are not changing the direction, whether you take the mean of these two quantity just by adding their magnitude, yani scalar addition or the vector addition, it will not disturb it. But if there is change of direction of the initial velocity, final velocity, both or any of that, then you have to take care of the direction also. So that's why vector u plus vector v divided by 2. Let us say u is at an angle of theta. Then here you will have u cos theta and this is u sin theta. Here you will have, suppose this is at an angle of, this v is at an angle of alpha. Then again you will have v cos alpha and you will have v sin alpha along this direction. Taking care of that v cos alpha, v sin alpha, because first you have to calculate mean along x-axis. So that will be u cos theta plus v cos alpha upon 2. Again y component, mean along y component, that will be u sin theta plus v sin alpha divided by 2. Because these two are along y-axis and these two are along x-axis. So simply we can add and we can divide by 2. So that will be again mean velocity along x as well as mean velocity along y. Then you have to find the resultant of that. Resultant along x-axis and y-axis, if these two parameters are known, then how to calculate? So x component square plus y component square is square root. So from there you will be able to get the mean velocity. So those things you have to do before you calculate it. So here, if there is change of direction, then you have to consider the vector addition, use that and simplify, you will get the mean velocity. I hope this is clear. Now, there is only one concept in general, mean, because average and mean, in English we say it is same, meaning of mean or average it is same. But here numerically, mean and average, numerically I am using the word numerically, conceptually it is different. Here it is displacement upon total time taken. Here it is the initial velocity plus final velocity divided by 2. Conceptually they are different, but numerically there is only one situation. Conceptually as well as numerically both are different, but there is only one situation where numerically mean velocity it will be same as average velocity. Either you calculate using this relation or you calculate using this relation, you will get the same value, and that is strictly if the particle is moving on a straight line path, then in that case numerical value of mean velocity it will be same as average velocity. If there is any change in the direction, then it won't work. Then mean velocity it will be different from average velocity. So that you have to take care. Numerically mean velocity is same as average velocity provided it is strictly along a straight line motion, if it is a straight line motion. Otherwise, in all other different situations, numerically and conceptually mean velocity it is different from the average velocity.